Hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and in today's video we're going to continue on the steady rest. This project is turning out to be a bit longer than I anticipated at the beginning, but hopefully today we can pretty much bring this to a stop, at least a stopping point or ending point for now. I may come back later and do some more enhancements to it. But what we want to do today is, when we left off in the last video, you saw that I had got the legs cut out, roughed out, got the center hole bored out to its finished diameter. And what we need to do next is take the outside of it and make that round. Now, off camera, I carried the workpiece over to the bandsaw and trimmed the top right side of our piece. I found that when I was cutting with the bandsaw, trying to change the weight distribution a little bit in the last video, that it was somewhat hard to keep that bandsaw blade tracking close to the line. And so when I did that roughing out in the last video, I stayed 200 thousandths off the line, which I knew was going to mean a lot more work on the mill. When I was cutting these corners off, as I said, I started with the top right, then I went to the bottom right, cut that off, and then the bottom left. But as I was doing that, I developed a technique, or stumbled upon a technique, that helped me get within probably 10 thousandths of my outside line that I had scribed. So what I've done, I've saved one corner right here, the top left. We're going to carry that over to the bandsaw, and I'm going to show you how I get that down within, I'm sure you can't see it in there, but it's within 10 thousandths of my line. After we do that, we're going to set the rotary table up on the mill and finish this edge. It's a very rough edge that's on there now, but we're going to finish that. And then, I think for now, for the time being, I'm going to use the same 3 fingers that was in the original one. They'll be a little bit short, but I'm going to mill out while we're on the rotary table, 120 degrees in each from the center. I'm going to mill out for those same fingers that were on the original steady rest. As I say, they're a little bit short since I'm making this a little bigger, but I want to put roller bearings on the end as well. And I'm going to do my best to get to that in this video as well. So let's turn over to the bandsaw now and take this final corner off. I'm over at the upright bandsaw now, vertical bandsaw. This is the one that I made in a previous video, or made the stand for. It's a portable bandsaw in a semi-permanent vertical mount. Now, when I was taking these chunks out from in here, again to get the weight pretty evened out, as I said earlier, I had to stay off this line. I could get fairly close to these, but cutting around this outside diameter right here, trying to cut and turn this piece as I was going, as thick as it is and as wide as that blade is, I was having difficulty staying close to the lines, so I wound up staying as much as 200 thousandths off the line, approximately. But what I found in cutting these corners off is, if I'll come over here and my line is still there, if I'll cut straight in almost to the line, move over about a 1/4 inch, make another cut, make another cut, make another cut all the way down, turn it, do the same way this way. Then as I start this swing around, I've only got to keep the blade for about 1/4 of an inch. Keep it close to the line. Let's see how that works out. Alright, hopefully you can see what I've done here. I've just cut notches down in each direction to right up to the line, but not touching the line. Now all I've got to do is control the blade enough to just maintain control of the blade just enough to cut out these individual teeth. Now that I've got that tooth there cut out of the way, I can maneuver the piece on around to closely follow this line. All right, I'll make one more comment before I cut out these final 3 teeth here, 4 teeth. Is as I'm cutting that, by having that notch in there, that gives me something to aim for without trying to keep that line in sight at all times. So that line is getting pretty weak now from the die-chem just wearing out. But this gives me something to aim my saw cut to that next cut, because I know I didn't go into the line on it. Okay, maybe I pushed just a little bit too much on that getting here in the end, and I broke that blade. That's not a big deal. I'll change that blade and get these last 2 teeth off. Okay, that didn't take about 5 minutes to get a new blade on. All right, there we have our outside diameter roughed out now. All told, I think it probably took maybe 45 minutes to cut this outside diameter to the rough finish it is now. Now I've already cleaned these up. Like I say, I rough cut them, that edge, this, and this, to try to get some weight off in the last video. The way I cleaned these up, while this still had the flat surfaces on each side, I simply set it up in the mill using the 20-degree angle block. Remember, these were at 20 degrees. Set that up on the 20-degree angle block and milled that down to my scribe line. Turned it over, put the angle block on the other side, remembering this had flat sides at that point, and milled this one down. To clean these up was a little bit harder to get into. You remember we had set it up like this in the previous video and milled the finished surface here. I carried this over to the 2x72 belt sander and just clean those edges up on each side right there. So I'm satisfied with all this down here, but now I want to go to the mill and put my little rotary table on with the outside jaws to clamp on the inside of this, and then try to run a finishing end mill around this outside surface. So I'll meet you back over at the mill when I got the rotary table set up. Okay, I got the rotary table set up on the mill now, and there's a whole lot going on here. I didn't try to bring y'all along for the setup, but I want to quickly explain to you what I've done. First off, I set the rotary table up, got it square with the mill table. I then located center of the rotary table. It does have the chuck on it, and the chuck is centered on the rotary table. So I located center in both directions. Now over here on this side, I wanted to be sure that my legs were perpendicular as well. So what I did was take this angle block and squared it up on the table. Now it wasn't quite tall enough to reach the legs, so I just clamped this piece, C-clamped this piece of flat stock on there. And I kept bumping this up, keeping this square, and loosened the chuck jaws until I got the legs lined up with the flat surface. Now, we're going around this to do this outside. It really didn't matter where this started. But I want everything set at a point where, should I ever decide to come back and make larger fingers for this, I can repeat this setup. So I've got the rotary table set on 0 down here. I've got my DRO zeroed out in the center. I found the center with the center finder in the chuck in here. So everything is centered here, and this is perpendicular to the table. So once we get this outside cleaned up here, which is the first thing we're going to do, then we're going to move over here and mill out a slot for one of the fingers. Remember I said earlier I'm going to use the same fingers from the original steady rest. We'll mill out a slot over here. Then on this dial we'll go 120 degrees in one direction and mill out another slot. That'll be around over here then. And go 120 in the other direction and mill out the third slot. And as I said, I may come back one day and make larger fingers here. And if I do, I should be able to completely repeat this setup. Our first calculation we need to do, though, is determine where to move the table over so that we have this cutter on the outside edge. Okay, we're starting out at the center of our workpiece. And if you recall, back over on the workbench in the previous video, we said this outside diameter here was going to be 5.5 inches. Now remember, we laid that out with a set of dividers and a simple markings on the rule. So it may not be exactly 5.5 inches, but that's what we're going to start with. So we're going to need to move this over half of that, the radius of the 5.5, plus half the distance of this end mill, half the thickness of this end mill. Now most of you can do that in your head, but we're going to turn up again to this little program that I have running on a Raspberry Pi and got it mounted in between the mill and the lathe. Okay, as I said, most of you, I feel certain, could do this bit of math in your head. But what we're going to do, using my little machinist applets program that I've talked about before, we'll select the applet called Equation Solver. We'll open parens, 5.5 divided by 2. Oops. Close parentheses. That'll give us the radius of the outside diameter. We want to add to that half of the end mill. 0.5 divided by 2. And again, I think most of you can do that in your head. 3.0. So we need to move the table over to where the DRO will read 3.0. Alright, as you can see now, the DRO is on 0 and we're centered up on our workpiece. We want to move the workpiece over to 3.0 that we calculated. And we'll lock the x-axis on the table, on the mill table. We've got it locked down. So what that's done is move our workpiece over to this outside edge. Alright, let's unlock the rotary table. Oh, no wonder I couldn't get it to move. I still got this apparatus sitting down here. Alright, we got that out of the way now. The rotary table should rotate now. It's going to take a pretty hefty chunk out right at this point here. I'm going to move over, actually I'm going to move over 25 more thousandths. What I want to do is get a feel back for what it's going to, get a feel for what it's going to do and how much it's going to be cutting. And you know what, I started in the wrong direction, because if I go, let's see, I don't want a climb mill. Y'all can tell I hadn't rehearsed this by any means. Alright, let's make a, yeah, that's going to climb mill there. So let me quickly move to the other side. I'm going to come back toward, a little bit more towards 0 now. And I'm going to make one pass right there. And it's just touching in a few places now. Now we're starting to get a little bite. As you can see right there, it's just starting to cut these high spots I left when I was roughing out. Alright, I'm going to continue this process going round and round until we get a whole lot closer. Alright guys, I'll bring you back when I'm getting closer and doing a lot more cleanup. Right now I'm just hitting these high edges, and I got quite a ways to go to get it to where it'll be a bit more interesting than it is right now. Okay, we're getting down closer now. We still got a couple low spots. Right there's one, and there's a few on around, and about 2/3 the way over, right here on this far side, I got one low spot right in there. But let's make another round right quick. I switched back to the rough and end mill just to get this down to where I got a same plane all the way around. I'll go back to the regular 4-fluid end mill to give it a final cleanup cut in the end. Alright, right in here is where we start running into some low spots again. But there was a whole lot more of them to begin with than there is now. Right here toward the end is one of the deepest spots. Right in there. Alright, I'm going to bring it back around, take a few more thousandths, then I'll bring you back when I get ready to put the finishing end mill in. Okay, I think this is going to be the last time around with the roughing end mill. We got one little spot left over here on this, right at this end. That corner up in there, I'll have to get up in there with a flap disc probably and clean that out. Alright, that last little spot should be coming out of the shadow now. Let's see if this cleans it up. Right there. It didn't sound like it quite cleaned it up. Nope, we still got a little more. Alright, I'm going to make another round or two if it takes it with the roughing end mill. Then I'll put the finish end mill in. Okay, I've got the finish end mill in now. And I'm making what I hope will be the last pass. Taking it nice and slow. As I said in the first video in this series, I have to keep reminding myself that this is a steady rest, and there's adjustment in 3 different directions on it, but I do want to try to make it as nice as I can at this point anyhow. Okay, just to be sure that the steady rest didn't twist on the vise, which I can't imagine how it would, but I've set my jig back up down here, square with the table, and checking this, and that's all square. So we should be ready now to cut a slot in here, move 120 degrees this direction, cut a slot 120 degrees in the other direction, and cut another slot. Okay, to make our slots through, they need to be 0.5 inches deep and 710 thousandths wide. I've got a 7/16 end mill in now, and so we'll go down to the 0.5 depth, and then just keep working side to side until we have our width of 17. I do have the dials set here on 0 and 0 at this point, and the rotary table locked down. I did zero out the DRO up here before I started cutting. Okay, this should be our last pass to get the proper depth. There's 500 thousandths. Okay, as I said, that should be 710 thousandths wide. I'm using a 7/16 bit in there, so the difference in that is 273 thousandths divided by 2. That's 136 on each side. We're going to step over. DRO still on 0. I'm just going to step over about 25 thousandths at a time. We're working on this side now. All right, now we're right here. That was 25 thousandths. I'll step over 25 thousandths on the other side. Now I'll go back to 50 thousandths on this first side. And I'll just keep working that back and forth. And like I say, I'll go 100 thousandths each side to begin with and then start measuring. Okay, I know I still got a ways to go here, but I'm going to use a set of adjustable parallels. And get my depth right there. Get my width. Measure that. That's 650. And we're looking 710. So that's 60 more thousandths, 30 on each side. All right, I stopped at 115 thousandths. So if we go to 130 thousandths, I want this to be a pretty good fit. So I'm going to kind of sneak up on that. I'll keep doing this on both sides, measuring between each cut until I come up with a good fit. Okay, I think we've got our first groove cut out. That fits in. Got just a little bit of play, maybe a couple thousandths in there, but that should help it seat in and out. Okay. Got to do that 2 more times. So what I'm going to do is loosen, of course, my rotary table, and we're going to go to 120 degrees, which is 1/3 of 360, of course. And I'll do the same thing right here. Mill another slot down. Once I get that to size, we'll come back over 120 degrees in the other direction, or 240 on around this way. Once I get that done, I'll go back to the 0 position here and drill this 8 or 10 millimeter hole in each of the 3 locations. Okay, I've got all 3 of the slots milled out now at 120 degrees from each other. One more step we need to do here on the while we're on the rotary table, and that is drill a hole for the bolt in each of these 3 slots. Okay, I think we're about to the point where we're going to have to wrap this video up. It's running long as well. Pretty sure in the next video we'll be able to wind this up, at least get it to a usable point and a good place to stop on this project for now. I may come back to it later, like I said before, and make some larger fingers to go in. But in the next video, what we'll do is mount the ball bearings on the ends here, and also get the base that we made in the first video in this series, get it mounted to the upright. If you've stuck with me this long, I appreciate it. This project is considerably more involved than I imagined to begin with, or it's taken more time than I envisioned to start with. But again, I appreciate you sticking with me. I'll see you in the next video.